Here we have another definite integrals example problem, and we want to evaluate the following definite integral. The integral from 3 to 5 of 4t divided by 2 minus 8t squared dt. So this one is interesting because we'll do some u substitution, and then we also have to watch out for our discontinuities, and then we can modify our boundary conditions as well. So this one has a lot going on, and we'll get into it. So the first step is we want to verify that our divide by zero discontinuities are outside of our boundary conditions. This is important because if our discontinuities are within our boundary conditions 3 and 5, then we know that we won't be able to take the integral over those bounds. So let's go ahead and look at that. 2 minus 8t squared is equal to 0. This is what we'll do to determine our location where t is equal to 0. So we'll have 8t squared is equal to 2. We can simplify that to get t squared is equal to 2 over 8, which is 1/4. And then we can take the square root and get t is equal to plus or minus 1/2. So we know that t cannot equal negative 1/2 and 1/2, or else it'll give us a division by zero error. And this is outside of our boundaries, which are 3 and 5. So we know that we can go ahead and take the integral of this example problem. So we'll go ahead and do that. So the next step is we want to integrate using u substitution. So we'll take this bottom term, we'll let that term be equal to u, and then we can go ahead and take the derivative to get du, which is going to be equal to negative 16t. Do some simplification to get negative 1/16t is equal to t. And the last step is we want to convert our boundaries from 3 and 5, which is in terms of t, to bounds that are in terms of u. So all we have to do is plug in 3 into our t term for u to get our boundary for u. So when we have u of 3, it's going to transition to be negative 70, and when we have u of 5, it's going to transition to be negative 198. The last step is we can go ahead and reset our bounds and plug in our u term. And so here we have it after some simplification, negative 1/4, the integral from negative 70 to negative 198 of 1 over u du. And we know that the integral of 1 over u du is really just ln of u. You can see that here. And so we'll evaluate this ln of u. And the key thing here is absolute value of u from negative 198 to negative 70. And so you can see here, we're just plugging in those terms. And because we have the absolute value, these two terms will become positive. And then here we have our solution to this example problem.